Hello everyone. Today we're going to go into a sorting algorithm called bucket sort. Let me just start the slideshow. Alright, now if you've ever had a messy drawer or pile of random stuff and just tried to organize it, you kind of already get the idea behind this, but we're going to go through it step by step, and by the end you'll know exactly how it works and when to use it. So, imagine you've got a list of numbers, like test scores, or random numbers between 0 and 10,000 for no particular reason, and you want to sort them from smallest to largest. You could use algorithms like bubble sort or insertion sort, but bucket sort does something a little different. Instead of looking at every single number over and over and moving it, it splits the problem into smaller and more manageable chunks and then sorts those individually. So, think of bucket sort like having a set of empty buckets. Literally, buckets. And you're going to drop each number into the bucket that matches its value range. So if your numbers are 0 to 100, bucket 0 might hold 0 to 10, bucket 1 holds 11 to 20, bucket 2 holds 21 to 30, and so on. Each number goes into the bucket that it will belong to. So I'm actually going to help us visualize this for a second. No, that's not it. This one. All right. So, imagine these numbers: 12, 45, 23, 67, 3, and 89. So let's draw a few buckets on the screen. So my buckets are just these little squares. I have no clue why that one is there. Now we place each number in the right bucket. So 3, for example, we will take and we will put it into 0 to 20. All right. 12, we're going to put it into 0 to 20 as well, since it also matches that range. Oh, it's small. There we go. 23 is no longer in that range. So, oh, what's happening? I gotta go over here. All right. So 23, we also take, and this one is above the range of the first one, so we put it into the second bucket. And then the next one is 45. So we take that one too, and we put that in the next one because it no longer fits 21 to 40. Now this is done with simple math, and code easily does this. And as we continue and sort everything into each respective bucket, like so, now our numbers are grouped into smaller, sorted-ish sections. You can see it's way easier to handle smaller groups than the entire list at once. So let's go back to the slideshow. Oh, skip past this slide again. Yeah, I was meant to switch to that. So once the numbers are in the right buckets, the next step is to sort each bucket individually. Usually you can use a simple algorithm like insertion sort here. Why? Because each bucket will only have a few numbers anyway, so even simple sorting will be super fast. Sorting small groups is way quicker than sorting the entire list at once. Oh, let's go back. And now let's go to the code that I have. Let's go over here. Oh, that's not the right slide. Great. So, after sorting each bucket, all you do is you take the numbers out the buckets in order, starting from the smallest bucket. Then you put them together, and now you have a fully sorted list. It's kind of like cleaning up a messy room by sorting your stuff into boxes and then stacking them back up neatly. So, merging these buckets happens in this last part of bucket sort, which is concatenate all buckets into one array. So, what happens initially in the code is you find the maximum value, then you create empty buckets to fill the entire array. So you see n is array.length. Then you put the elements into different buckets as I explained earlier. Then you sort the individual buckets using insertion sort, which I have right here. And then you concatenate all the buckets by creating an index, and then simply adding to the index and adding, adding the current value into the index, which adds every time, which adds basically to the first value, and to the second value, and to the third value, creating a full sorted array. Let's go back to the slide. Oh, why is it doing that? When is it helpful? Now, bucket sort is especially efficient when numbers are evenly distributed across a range. Instead of comparing every number to every other number like bubble sort does, bucket sort breaks it down. You only sort within buckets, so it reduces the numbers of comparisons and shifts you need to do. So you can also think of it like sorting mail, for example. You have a bunch of letters for different zip codes. You first separate the letters by zip code. That's like putting the numbers into buckets. Then within each zip code, you arrange the letters by house number. That's sorting within the bucket. Finally, you deliver all the letters in order, which is merging the buckets. Let's go over a quick overview on the code. So, go over here, and I did kind of already explain this, but just to break it down one more time, make it more simple to understand. So first, you find the maximum number in your list, so you can figure out the bucket ranges right here. Then, you create a bunch of empty buckets right here. It's based on the number of elements. After that, you place each number into a bucket based on its value, which is right here. Secondly, after that, you sort each bucket using a simple sorting method like insertion sort, or you can use another one. And finally, you merge all the buckets together, and you get a sorted array. And there you have it, bucket sort. It's fast, simple for distributed numbers, and really easy to visualize. The next time you need to sort a large group of numbers, try thinking about buckets instead of comparing every single number. Thanks for watching, and I hope this gives you a clear picture of how bucket sort works. It also initially surprised me that it uses so little comparisons and loops. Later, sir. End video.